Okay. So today we will just do an introduction to trigonometry, and let me see what are the things that you already know, and if there are things which needs to be taught before starting doing questions, then we can do that as well. So it's hung up now. Okay, it will take 15 more seconds to resolve. Okay, fine. So first of all, if I talk about trigonometry, I will talk about a triangle which is right angle triangle.
Right angle. Oh, I've already learned this.
Okay.
Cos, tan.
You know about sine, cos and tan?
Yeah.
Okay. So let us suppose that this is a right angle triangle ABC. And if I ask you, can you tell me what is sine A?
What do you mean? Like,
How should I define sine A? What is the ratio of the sides?
oh, sine A would be.
Yes.
So then what's the angle? Which one would the angle be?
Okay, so vertex is the angle. If nothing is given, so A means A is the angle. So how many angles are there in this triangle? Tell me.
3.
What are they?
It would be it would be, I know this, wait, let me, because it's Sokotoa, so if this is, it would be the line between B and C over the line between A and C.
Okay, so that means you are saying it is BC upon AC.
Yeah.
Can you tell me what will be cos A?
Cos A would be, it would be AB
Okay.
over AC.
Very good. Can you tell me what will be tan A?
Tan A would be BC over AB.
Very good. Now if I ask you, tell me what is cos of C? What is cos of C?
It would be, wait.
Okay.
It would be cos BC over AC.
BC over AC.
Yeah.
Very good. What will be sin C?
Sin C would be AB over AC.
AB over AC. What will be cot C?
What's cot C?
You don't know what is cot?
No.
Cotangent. You have learned only 3.
Yeah.
Sine, cos and tan.
Yeah.
Okay. So they are reciprocal of. You have learned what is 1 upon tan A? That is known as cot, cotangent. No?
I haven't learned that. No.
Okay. So that means it needs to be learned. Okay. So there is a relationship between a triangle and the angles between them. Now what is the relationship between the sides of the triangle and the angles between them? The relationships comes into 3 pairs. Suppose there is A, there is B and there is C. And if I ask you to have a relationship of 2 pairs, means pairing, just I wanted to pair it. So what are the possible pairs that you can make out? Tell me, what are the possible pairs that you can make out from A, B and C?
A, B.
So you can do AB, very good.
BC.
You can do BC, very good.
AC.
You can do AC as well. Very good. And you can just reverse it as well. That means you
Yeah.
can say it can be BA, it can be CB, it can be CA. Are you getting it? But both are equal only. They are kind of same thing only. So if I ask you, if I am going to divide these three numbers, what are the possible ways that I can divide? So you can say either you can do A by B, or you can do B by C, or you can do C by A, and you can reciprocate it. That means you can do B by A, you can do C by B, and you can do A by C. These are the 6 basic things that we get from 3 variable things. If we are having 3 things, we get 6 pairs like this. In the form of ratios, we can say these are form of ratios. Now in these form of ratios, if I bring it to a triangle, and let us say that this is A, this is B, this is C, the first ratio, that is opposite side upon hypotenuse, that means I say BC upon AC. You know, in a triangle, do you know about this, that the largest angle, the side opposite to the largest angle is the largest side? You know about this theorem, triangle inequality? No?
Yeah, and it's called hypotenuse.
That is hypotenuse.
Yeah.
Because 90 degree is the largest angle that a triangle can have in a right angle triangle. You can't have another angle which is more than 90. It can't be even equal to 90, because both, then how it can be a triangle? It will be only 2 angles. So if this angle is 90 degree, this side is known as hypotenuse. So first we will have a relationship between, suppose I am putting my eye on this side.
Okay, yeah.
So if I look from here, this is the opposite side that I am watching.
Yeah.
So
And then the bottom is the adjacent side.
Yeah, so opposite side upon hypotenuse, that means BC upon AC is known as sine A. The full form is SINE, sine. SINE, sine. Okay?
I've learned this.
Yes. But what you haven't learned is, can you tell me what is cosine then? How the word cosine has came? What is co represents?
Cosine is, wait.
Don't tell me the ratio. I am asking you what is co means. You are having sine. What does co stands for? Cosine means, what is cosine? What does co stands for?
Cosine is the adjacent over the.
That is the ratio that you are saying, beta. But cosine is actually the complementary angle of sine. Co means complementary angle. What does co represent? Complementary angles. Can you tell me what are complementary angles?
When that like that the same angle and they're opposite each other.
Huh?
They're opposite each other, so they.
No. Opposite to each other, they are known as vertically opposite. Complementary angles. This is the spelling. What are complementary angles? Do you have any knowledge about these complementary angles? If I ask you to define what are complementary angles?
I do, but
I don't remember now.
But I don't remember.
Yeah, fine. So complementary angles are the pair of angles whose sum is equal to 90 degree.
Oh, I could see it was 180.
That is supplementary angles. Okay. Supplementary angle means the sum of the angle is 180 degree, but complementary angle means the sum of the angle is 90 degree. Now if one of the angle is 90 degree, serious, if one of the angle is 90 degree, can I say that angle A and angle C are complementary angles?
Yeah.
So that means if I say sine A is equal to BC upon AC, I can say that this is equal to complementary angles of cosine, cos of C. Are you getting this?
Yeah.
Sine A is equal to cos C. Why? Because A and C are what kind of angles? Complementary angles.
Yeah.
Okay, and let us see how good you are in calculations of complementary angles. I will give you one angle. You have to tell me another angle whose sum will be equal to 90. So if one of the angle is 40, can you tell me what is the other angle?
50.
Very good. So can I say that sine 40 is equal to cos 50? Are you getting it?
Yeah.
Have you learned this before?
No.
Okay. Can you tell me what is sine 1 equal to?
Sine 1 is equal to cos 89.
Yeah, you have to be quick. What is sine 30 degree equal to?
Cos 60.
What is sine 60 degree equal to?
Cos 30.
Very good. What is sine 45 degree equal to?
Cos 45.
And what is sine 0 is equal to?
Cos 90.
Very good. What is sine 90 is equal to?
Cos 0.
Wonderful. So now you have understood that sine and cos are not just the ratio of the sides of a triangle, but also complementary angles of each other, and they are the complementary ratios as well. Sine 90 and cos 0 both are same only.
Yeah.
Okay, and if you look from this side or you look from this side, the side which is opposite in front of me is actually the base. If I look from here, if I stand here and look at this place, this is going to be my base, because I can stand only on base. What is base? Base is, the earth is a base. The earth is a base. If you are standing on a tower, the tower becomes the base. Are you getting it?
Yeah.
So the side which you look opposite is known as opposite side, but the side which you are standing is the base. So this is perpendicular, this is base, and in general we call it, not to get confused, we call it opposite side for the perpendicular and the adjacent side for the base. All right.
Yeah.
Okay. So the two trigonometric ratios you have learnt now, that is sine and cos. Now moving on further, there are two more trigonometric ratios which are also complementary of each other. Those are known as tan means tangent, and then there is a cotangent which is termed as cot. In small we say it as cot. So what is tan? If I ask you what is tan A, you can say it will be equal to cot C.
Okay.
Tan A will be equal to cot C, because again A and C are complementary angles. And what is tan A is equal to? You will say it is opposite side upon base, that is BC upon AB.
Okay.
And if I ask you what is tan 30 degree, can you tell me what is tan 30 degree?
Cotangent
60 degree. You can say cotangent 60 degree.
Yeah.
All right. And do you know what is tangent? Where does that word tangent came from? What is tangent?
It's a thing in a circle, isn't it?
Yeah. What is that?
It's
See, you keep on looking in your notebook. You can't find anything. You just look in front and tell me if you remember it now. It's okay.
Tangent is the line next to the circle that's touching the circle.
It's touching the circle. So how many lines are there in a circle? There can be three kind of lines. One is intersecting the circle at 2 points. What this line is known as?
It's called a chord.
No. Chord is the line segment, beta. If I ask you about what is AB, you will say it is the line segment is the chord. But here it is not the chord. Here it is the secant. Secant is a line which intersects the circle at two different points. What is tangent? So if I keep moving this line, see, if I keep moving this line towards the center, it will become the diameter.
Yeah.
Means the chord becomes a diameter, and if I keep on taking it outside more and more closer to the vertex, there will be a point when it is going to touch the circle.
Yeah.
And when it is touching the circle at a single point, here comes the word tangent. Tangent means to touch.
Yeah.
So all the hardwares are tangent. In the computer, software you can't touch it. Can you touch Microsoft Excel?
Yeah.
You can't touch Microsoft Excel. You can work on Microsoft Excel. You can make use of.
You also touch the screen and then you're touching it.
No, you are not touching it. The cursor is touching. You are selecting it. There is a word, proper word, which is known as selecting the cell. You can select the word by just scrolling it, but you can't touch it. All right. How can you pick it up? You can't take it outside. You can take the printout of it, but you can't touch it. So all the softwares are, you can say, they are non-tangent, but the hardwares are tangent. I can touch this. I can touch this. This is a monitor keyboard. Okay, those input devices, we can touch all this. Okay, so you understood what is a tangent? Then there can be a line which cannot intersect, which does not touch the circle, so it is outside. So there are three kinds of lines in a circle. So we are talking about this tangent now. Tangent, tan A, that is equal to cot C, that means complementary angles. Cotangent, co means complementary. All right.
Yeah.
Then there is one more trigonometric ratio, two more. So one is known as secant. So secant is the reciprocal of cos. So yeah, so it will be, so secant of, so in short we write it as sec. So sec of A is actually AC upon AB.
Okay.
Okay, it is the reciprocal of cos. You can say what is cos? Cos is AB upon AC. So sec is AC upon AB. And the complementary of sec is known as cosecant. In short, we write CSC or we write cosec. So what is cosec A? It is AC upon BC.
Okay. Wait.
Yeah.
Cosec. Cosec A. What is cosec A equal?
A is that particular same angle.
So it's AC over BC.
Yes, AC over BC.
Okay. Oh shit, all of them have a complementary angle.
Okay. So again I am writing all the 6 trigonometric ratios now. So sine A is equal to BC upon AC. Cos A is equal to AB upon AC. Tan A is equal to BC upon AB. Then cosec A, that is the reciprocal of this,
Yeah.
is equal to, you just reciprocate it, AC upon BC, and sec of A is equal to AC upon AB, and then you have last cot A is equal to AB upon BC. All right.
Yeah. Wait,
Yeah. So these are the basic 6 trigonometric ratios. They are known as trigonometric ratios.
Yeah.
in which sine and cos are complementary of each other, cosec and sec are complementary of each other, and
Yeah.
tan and cot are complementary of each other. And there is one more relationship between tan and cot. So tan and cot are not only complementary to each other, but they are also reciprocal of each other.
Okay.
They are complementary and they are reciprocal of each other as well.
Hmm.
Okay.
Yeah. Wait. So. Yeah. Okay.
Now you must remember some Pythagorean triplets, because that will be required in these cases. So I'm going to make you remember the 7 Pythagoras triplets, and which will be very easy for you to remember. Till now, how many you remember? Can you tell me?
Of what?
Pythagorean triplets.
I don't know.
You know what is Pythagorean triplets?
I know what Pythagoras is.
Okay, you don't know Pythagorean triplets, you don't know?
No.
Okay. Pythagorean triplets means in a right angle triangle. You know already the Pythagoras theorem. The
Yeah.
Pythagoras theorem says the base square plus perpendicular square is equal to hypotenuse square. This is what it says.
Yeah. Is equals BC. A squared plus B squared equals C squared.
Okay. Then in that case, this will be C. So this is B, this is A.
Yeah.
The side opposite to angle A is known as small a, the side opposite to angle B is small b, the side opposite to small c, angle C is small c. So you are saying that A square plus B square is equal to C square. So ABC is known as Pythagorean triplets. What is there known as? Pythagorean triplets. So you must remember this. Then only if you keep on calculating this third side, it will take a lot of time. So let us remember.
Wait. Is that this? Read that.
Probably yes. I can see properly.
Okay, it's like.
You can send me the photo of that in the group. Then I will be able to take it out. Then we can discuss on that. If you can send me the photo.
I don't know if it is this, but I'll show you.
Yeah, show me. Okay. Okay, that is a different thing, beta. That is a completely different thing. Sine rule and cosine rule are the different thing. Okay, that is not Pythagorean triplet. Okay. So Pythagorean triplet means the three sides, the length of the three sides, which you remember that they form a Pythagoras triplet. So first is, can you tell me what is 3 square?
What do you mean?
What is 3 square? Square, you know. What is 3 into 3?
Oh, 9.
9. Can you tell me two numbers, two consecutive numbers, whose sum is 3 square?
4 and 5.
So the first Pythagoras triplet, welcome to first Pythagoras triplet, 3, 4 and 5. What is 3 square? What is 3 square? 9. What is 4 square? 16. And if you add them, what you are going to get? 5 square. That is 5 square. Alright.
Yeah.
Now can you tell me after 3 what is the next odd number?
5.
So what is 5 square?
25.
Can you tell me two consecutive numbers whose sum is 25?
12 and 13.
So welcome to the next Pythagoras triplet, that is 5, 12 and 13. So 5 square is how much? 25. 12 square is how much? 144. If you add them, it is going to be the 13 square.
Yeah.
Now you can make off your own. Can you tell me what is the next odd number?
7.
Can you tell me what is 7 square?
49.
Can you tell me what are the two numbers whose consecutive numbers whose sum is 49?
25.
So welcome to the next Pythagoras triplet, 7, 24 and 25. What is 7 square, beta? It is 49. What is 24 square? 576. If you add them, you are going to get 625, which is 25 square. So you must be well versed on this. Can you tell me the next one?
9. 40 and 41.
Can you tell me the next one?
11.
And there is one more apart from this league. We will learn this up to 11 only. So there is one more, 8, 15 and 70.
How come there's only one even number? How come there's only one even number?
One even number. So this is different. This is exception that I am showing.
Okay.
8, 15 and 17 is also a Pythagoras triplet. What is 8 square?
64.
What is 15 square? 225. If you add them, it will become 289, which is 17 square.
Yeah.
Then you have to remember one more, which is 20, 21 and 29.
Yeah.
20 square is 400. 21 square is 441. If you add them, it is going to be 841, which is 29 square. So 4 and 3, these are the basic 7 Pythagoras triplets which will come across in your life, and this will be required for you because you know from this you can make n number of Pythagoras triplets. Like for example, suppose the question gave you that sine A is equal to 3 by 5. Find all other trigonometric ratios. So you can easily say if it is 3, 5, then the third side is 4. So you can say that cos A is equal to 4 upon 5, then tan A. So tan A means you can divide this sine upon cos, so it is going to be 3 by 4. Do you know that tan is sine upon cos as well? No?
I didn't know.
Okay, so you must know this as well.
And
Let me show you.
some cos?
Yeah, I am showing you, don't worry.
Okay.
Can you tell me what is the difference between 2 by 5 and 2:5? Don't tell me they are same, they are not same.
They're not same.
Then tell me the difference.
2 to 5 is, I know the difference between
Yeah, I am
It's like-
listening.
2 to 5 is like 2 over 7 and 5 over 7.
What?
2 over 3 is 2 over 5.
What you are saying? What you said?
It's like 2 to 5 is 2 over 7 and 5 over 7.
Okay.
2 over 5 is 2 over 5.
2 over 5 means there was a big piece and there was 5 equal pieces and they took 2 out of it. But
Yes.
2:5 is, there are 7 pieces and we took 2 out of 7 and then we took 5 out of 7. This 7 and 7 got cancelled. So the ratio is 2:5. Mathematically, numerically, both are equal, but in the real life, they are not equal. Alright,
Yeah.
here there are 7 things, here there are only 5 things. But mathematically, if you compare them, 2/7, so suppose it is like this, 2/7 divided by 5/7. So you can do it like 2/7 multiply by 7/5. This will get cancelled out. So it is going to be 2/5. So mathematically they are equal. Now see this. Suppose this is A, this is B, this is C. Now suppose that sine A is BC upon AC. Cos A is AB upon AC.
Yeah.
If I ask you what is sine A upon cos A, you will say, sir, sine A is BC upon AC. And since you are dividing it by cos, that means we are multiplying by the reciprocal of cos. So what is the reciprocal of cos? It is AC upon AB.
Yeah.
AC will get cancelled out. So it is BC upon AB. Now, which is tan A. Please write down. Make a note of it.
Yeah.
All right. Okay. Similarly, if I ask you what is cot of A, so you will say it is cos A upon sine A. Cos A upon sine A. All right.
Yeah.
Okay. Now there are some trigonometric identities. So we will categorize into different parts. So the first category is reciprocal identities. So there are basically 3 reciprocal identities. The first identity is sine A cosec A is equal to 1,
Yeah.
because they are reciprocal of each other, and if you multiply two reciprocals you always get 1. All right.
Okay.
Then can you tell me what will be the other one? Cos A into sec A.
Second.
Sine is complementary angles, sec is
Yeah.
reciprocal.
Yeah.
Only for tan and cot both are complementary as well as reciprocal. So there are 3 basic reciprocal identities.
Okay.
Then there is a second category which is known as Pythagorean identities. What are Pythagorean identities? So the first identity is sine square A plus cos square A is equal to 1. Sine square A plus cos square A is equal to 1. Are you aware about this?
No.
Okay. So first I will prove it for you and then we will remember this. So suppose that this is a right angle triangle ABC. So can you tell me Can you tell me what is sine square a? See, you have to understand, beta, sine a whole square, to avoid the time, we don't put a bracket, so we put a square before a, between sine and a. We read it as sine square a, but in actual it is sine a whole square. Okay, so when I say sine square a, I am talking about sine a as a whole square. When I say cos square a, I am talking about cos a as a whole square. Okay, so it is different from sine a square. So when I write sine a square, I mean that the square of a is happening. But when I write sine square a or sine a whole square, I am talking about first calculate sine a and then do the square of it. Are you getting it?
Yeah.
So the first identity is sine square a plus cos square a is equal to 1. Let's prove it. So what is sine square a? We will say that it is BC upon AC whole square. What will be cos square a? It will be AB upon AC whole square.
Yeah.
Now both the numbers are having the same denominator, which is AC whole square. So the numerator will be as it is, they will be added. So BC square plus AB square. Now according to Pythagoras theorem, BC square plus AB square is how much? AC square. So which will be cancelled out and it will come as 1.
Yeah, okay.
Done?
Not yet. Wait, how did you get AC?
BC square plus AB square is how much? Pythagoras triplet. BC square plus AB square is how much? That is AC square only. In a right angle triangle, the sum of the square of the bases and the perpendicular is equal to hypotenuse square. So BC square plus AB square is equal to AC square. Tell me what's your doubt?
How? Because
Okay, you tell me 3 square plus 4 square is how much? 5 square. How it is 5 square? You don't know this?
you added it together.
Pythagoras theorem. You said a square plus b square is c square. You only said to me.
Yeah.
Are you aware of this?
Yeah.
So if I say that what is b square? It is ac square only. What is b square? It is ac square only.
Yeah.
What is a square? It is bc square only.
Yeah.
So if I add both of them, the square of both of them, what I will get? You said c square, which is ab square.
Yeah. Okay.
Understood now?
Yeah.
So if you have doubts, sir, how this comes, I can prove this as well. If you have a doubt on this, sir, how this comes, I can prove this as well. But if you are in a agreement, okay, you are in agreement with this,
Yes.
then you should be in agreement with this as well. The same thing I have used here. The base square is AB square and the perpendicular square is BC square. So if I add both the squares, I am going to get the hypotenuse square, which is AC square. And both the numerator and the denominator are same. So it will be cancelled and it will become 1. Any doubt?
Yeah. No doubt.
Okay. So what is the first identity? First Pythagorean identity? It is sine square A plus cos square A is equal to 1.
Yeah.
Now if I divide the whole equation by cos square a, if I divide the whole equation by cos square a, I am dividing the whole equation by cos square a. So what will happen to sin square a? What will happen to sin square a? Sin square a by cos square a is how much? I told you earlier. 10 square. And what will happen to cos square a? It will become 1.
What?
So it will become 1. And what will happen to 1? It will become 1 upon cos square a. So the cos square a will go up. So it will become sec square a. So the identity is 1 plus tan square a is equal to sec square a. This is the second Pythagorean identity.
Okay. Reading it right now.
Yeah, if you have any doubt, I can prove it again in front of you. I have explained it to you. If you have doubt, you can just ask me. We get this by dividing the first identity by cos square a. That's it.
Okay.
Any doubt?
No.
Now if I divide the first identity by sin square a, I am dividing it by sin square. So sin square by sin square will become 1. Cos square by sin square will become cot square a. And 1 by sin square a will become cosec square a. So these are the 3 Pythagorean identities that you should remember. Please note it down.
Done.
Done. Understood the proof as well?
Yeah.
So this came by dividing equation 1 by sin square a.
Yeah.
So this came by dividing equation 1 by cos square a. Understood?
Yeah.
Okay.
Reading right now.
And this is the normal Pythagoras theorem. We just replace the value of sin a and cos a and we got as 1 only.
Yeah. Okay, done.
Done?
Yeah.
Okay. So reciprocal identity 3 and 3 Pythagorean identities as well. And now this plays very important role, you know. So for that I want to know whether you have any idea about irrational numbers.
What numbers?
Irrational numbers.
I've heard of them. Maybe I know them. I forgot.
Square root of 3. Square root of 2. They are irrational numbers. You cannot write them in the form of p by q, where p and q are integers and q is not equal to 0. So if you know the number system, if you know, remember the number system, the first kind of number is natural number. The second kind of subset of number system is whole numbers. Then comes the integers. Then comes the rational numbers. With them parallelly there are irrational numbers. Together they form real numbers. And after that we get complex numbers. So I am just asking you whether you are aware about this irrational numbers. Are you aware about rational numbers?
I don't think so.
Rational number also you don't know. Do you know about what are natural numbers?
No. I don't think I know numbers.
So natural numbers are the numbers which start from 1. Naturally, if I start you counting, you will say 1, 2, 3, 4 and goes up to infinity.
Yeah.
So the natural numbers are whole numbers when you add 0 to it. So 0, 1, 2, and you keep on going like this up to infinity. So these are whole numbers. And if you add negative numbers to it, like minus infinity, -2, -1, 0, 1, positive and negative both numbers, they are forming integers.
Yeah.
And if I write any numbers like this,
Wait, so then what's the difference between natural and whole?
0,
Oh, that's it.
that's it, only 0.
Okay.
0 might be looking small, but it is not that small as well.
Yeah.
So integers means negative numbers included. Rational means fractions are also now included. So that means now you can talk about 5 by 3, you can talk about 3 by 5, you can talk about those numbers which can be written in the form of P by Q. P by Q. And you can also talk about the numbers which cannot be written in the form of P by Q. That means square root of 2, square root of 3, square root of 5, pi. Pi is also an irrational number. The approximately value is 22 by 7, but that is not the exact value. So it is an irrational number. Understood?
Yeah.
So in the game of irrational numbers, this identity plays very important role.
Wait, so what's rational numbers?
Rational numbers? I told you the fractions also got included. The fractions.
Just fractions.
No, including fractions. Apart from all these numbers, including fractions. It is not only fractions. Including fractions. See, any number can be written in the form of P by. You tell me any number. Tell me any number of your choice. Let us say 100. 40. 40 can be written as 40 by 1. 40 can be written as 40 by 1. 40 means it is.
What did he say?
I said any number which can be written in the form of numerator over denominator is a rational number.
Okay.
Any number which can be written, let me define it as well. So a number which can be written in the form of P by Q, where P and Q belongs to integers. So Z is a symbol used to denote integers.
Yeah.
So Z means integers. This symbol means belongs to.
Okay.
So I'm using more often symbols, so you should understand. So P and Q belongs to integers, and there is a rule: Q cannot be equal to 0, are known as rational numbers. Okay, they are known as rational numbers.
Okay.
So there are two kinds of representation of rational numbers. One is decimal representation. So decimal representation is like if I say 1.5 or if I say 1.5 bar. There are two kinds of rational numbers. One is written like this, one is written like this. So this is known as terminating decimal. This is known as terminating decimal. This is known as repeating decimal. The decimal keeps on repeating. It is coming 5, 5, 5, 5, 5.
Yeah.
How you can write for this as a rational form? Can you tell me how you will write 1.5 as a rational form?
1.5 in the rational form would be
15 by 10.
15.
And what will be the rational form of 1.5 bar?
Because
It will be 14 by 9. You just reduce it by 1. Reduce the numerator and the denominator by 1. You will get the rational form. Let us see. Calculate. See, 14 by 9. Can you see it is going 1.55555 like this? Okay. Can you tell me what will be the rational form of 1.4 bar?
it would be 13 over 9.
Very good. Can you tell me what will be the rational form of 2.4 bar?
Would it be 23 over 19?
19.
Yeah.
Okay. So it is going to be,
It would be 11 over 9. Right?
see this. The 2 can be written as 2 and 0.4 bar can be written as 4 by 9. So 9 into 2 is 18 plus 4, 22 by 9. So it becomes 22 by 9. We can have a check on it. See this? 2.44444. And the display has ended, but it will keep on getting up to infinite decimals. So there are basically two kinds of decimal system for a rational number. One is either denominator with 10, or we can say with 2 or 5, and other than 2 and 5. If the denominator is other than 2 and 5, you can't see 2 and 5 here, but there is 2 and 5 here. The 10 can be written as 2 into 5. So if the denominator is of the form 2 and 5, it is always going to be terminating decimal. And if the denominator is other than 2 and 5, you can see 9 here. So it is always repeating decimal. It is always repeating decimal. Understood? I think for today's class it's 1 hour. I don't know how it passed. I didn't got to know. Okay. So you enjoyed the class?
Yeah.
Fine. So let's meet tomorrow if that's okay for you. So up to when is your holidays?
It's up till September, I think. It starts in like beginning of September. But can we do lessons like 2 or 3 times a week?
Whatever you say, I'm at your service. If you say once a week, I will do once a week. If you say all days a week, I will do all days a week. If you say only twice a week, I will do twice a week. It's not from my side. It's, see, you are my client. So whenever you will be asked a service, I will provide the service. I am a service provider. I am not going to teach you, okay, come and please learn from me. It is not like that. Okay, it is like when you are interested, I am available, we can have a class. If you are not interested for some other reason, you can just let me know. It doesn't matter. It's okay. I have a lot of work to do. So when there is no class, I will be doing something else. Okay.
Yeah.
So you just let me know, sir, today can we have a class? But please let me know in advance. Or if I make up some plan for a movie or something like that, I have to manage it. I can't cancel it. Okay. Because these classes are very late night.
Yeah.
So if you can let me in advance, then it will be more easier for me to plan for the next classes.
Yeah.
Okay.
Okay, so I'll ask my parents and figure it out and then tell you in the group chat.
Yeah, please let me know what are the 3 days or 4 days or 5 days or only 2 days. Whatever, just fix the days so that we can have a better engagement. All right.
Yeah.
And you want the PDF of all these things?
I've written down all of it, so.
If you want a PDF, I can share it with you right now. You want?
Sure, yeah.
I can send in the group then. Okay.
Okay.
Chalo. Bye.
Bye.
Bye, beta.